Welcome back. So now we're going to talk about the prefix sum. Prefix sum is one of those patterns that looks simple but unlock a lot of problems related to subarrays, ranges, optimization. Okay. So just imagine someone is saying to you, I will ask multiple times what is the sum of the number between the two index. Suppose here L, this is R. There are multiple arrays is there. Someone is saying I will ask you sum of the array between left index and right index, and I can ask you anytime. Like suppose when every move on the L, suppose L is coming here or L is coming here, again I'm asking the sum. Okay. So so what should be the approach? Normally people is going to do, they are going to use one for loop from this index to this index. They are doing the operation of sum, right? Like L1 plus L2 plus L3 up to R, correct? So if there are many queries like that, so things will going to become worse. It's going to be slow, right? So what is the key idea here? Prefix sum says in this kind of scenario, why not pre-compute something one a time, and every time someone is asking, you can give this. Okay. So when someone is asking the answer, you can give this order of 1. So that is called prefix sum array. Okay. So so suppose one example I'm having 2 4 6 8, correct? If I'm asking, suppose this is 0 1 2 3, give me sum between 1 and 2. So we're going to do 4 plus 6 equal to 10, right? If someone is asking, give me sum between 0 to 3, then they're going to do 2 plus 4 plus 6 plus 8, right? 20. So prefix sum says, why not compute the sum till that point for each element? How? So I'm going to, for the same example, I'm going to do prefix 0 till here. There is no element, right, in previous, so it's a 2. Whatever number is there is true. Let's do prefix 1. First index, what is that? Then 2 plus 4, that is 6. Prefix 2. So 2 plus 4 plus 6, it's same. You can replace this with this, right? So it will become 6 plus 6, that is 12, right? Prefix 3, so you're going to do 12 plus 8, that is 20, correct? So now our array will become prefix sum array, what, 2 comma 6 comma 12 comma 20, correct? So now someone is asking the question, give me to find the sum from L to R. Okay, so so sum of, just pay attention here, sum of L to R, that will be equal to what? Prefix L to R. Okay, so prefix whatever R is there, you have to just subtract that start point, right? So prefix L minus 1. This is the formula. Let's validate this. Suppose I want to find out prefix 2. Okay, so prefix 2 is here. So 0 1 2 3, prefix 2. So what will become? Prefix R. Okay, I want to find out 0 to 2, correct? So prefix 2 means 12, right? And L is suppose 0, then minus 0 minus 1, that is nothing, right? So in case of index 0, we have to handle separately. If suppose someone is saying between 1 and 2, so 1 minus 1 0, so means 12 minus 0 index is nothing but 2, so it will become 10. So between 1 and 2, the sum is how much? Now someone is saying, okay, find the index between 1 to 3. So what you're going to do, this is your L, this is your right? So actually what should be 1 to 3. 1 is here, so it should be your formula 4. I mean, if you go here, this one 1 to 3. So 4 plus 6 plus 8, right? Ideally, in a naive method, 4 plus 6 plus 8 it should be. That is 18, correct? But with this formula, what we are going to do is now become this one. I'm simulating this. So 1 comma 3. So that is your prefix of r. So this is the array. So prefix of r means 3, means this one 20. 20 minus prefix of L minus 1, so prefix of 0, right? So 0 is nothing but 2, that is coming 18. Understood? So this prefix is already contains the cumulative sum. So just have to subtract the previous sum. Okay. So normally the naive approach for this, if someone is asking, can you give me the naive approach and naive code? So what are you going to do? So in this, you have to use the for loop, right? Which is start with I equal to L and it will go till I equal to less than equal to R, right? And I plus plus. It's just you have to do sum equal to sum plus array I, right? This is the naive approach. Okay. If you optimize these, then you have to calculate the first prefix sum. So in this kind of problem, normally we have two-step problem. Step 1, you have to build one array, that is prefix array, and this is going to take order of n, of course, right? But then step 2 is going to answer the query. So that is going to happen in order of 1, because everything is cumulative. So whatever they're asking, you just have to minus it. It's a very fixed step, right? So let's do some dry run for this so that you can clear with the problem. Suppose I'm having one array 3, 1, 4, 2 and 5. Okay. So step 1 says, let's build the prefix sum first. So prefix 0, that is equal to 3. Prefix 1, that is equal to previous plus current, right? So 3 plus 1, that is equal to 4. Then prefix 2, then this one prefix 1, 4 plus 4, that is 8. Prefix 3, 8, this one plus current element, that is 2, right? So this will become 10. In the same way, prefix 4, that is equal to 10 plus 5, that is 15, correct? So this is your prefix sum array. So it will become now 3, 4, 8, 10, 15. Now I have calculated. Now someone is asking, give me sum of 1, 3. Means L is 1. So I'm going to do what? Sum of R. So what is the sum of, let me find out the prefix. Prefix 3 is what? 10. And prefix L minus 1, that is prefix 0, right? That is equal to 0 equal to 3, right? So what is the sum now? Sum 1, 3, that is equal to 10 minus 3, that is 7, correct? Understood? So this is the answer, right? Even though you are going to do the naive approach, then also you can see 1, 2, 3. This is 1, 0, 1, 2, 3, 4. So 1 plus 4 plus 2, that is nothing but 7, correct? So hope you understood this problem. So there are many use cases of this concept. So whenever you see multiple range sum query, sub array problem, or sum from left to right, or you have to count sub array with some k, okay, so probably this problem can be solved, this kind of problem, with the prefix sum. Okay, so remember that. Now we'll see multiple variant of this. So in the next video I'm going to solve this using the Java. I'll write the program for this. Okay, then we will see the other questions. Okay, let's see you in the next one.